Hello and welcome back to my channel. I'm Genoma, and today we have a little bit of a different setup. I have my computer on this side with a webcam. I'm running only on my laptop, so hopefully things will be smooth, but I cannot guarantee. And on this side I have my screen today, so I'm sorry if I'm not going to be looking too much on this side, and also if the microphone might be a little bit shaky, but hopefully everything will be fine. I am in the process of moving to a different apartment, and that's a good thing because I will soon have a space where I can actually dedicate time to record these videos and have a proper setup and so on. So I'm very looking forward to that. Today we are going to look at a project that I posted on my Instagram a while back at this point, and is I cannot even say inspired. It's literally been taken from Patrik Hübner, which is one of my favorite generative designers, and he has a ton of amazing work and also a lot of explorations. So I really suggest you go and take a look at his website. And yeah, quite a long time ago. I'm not even sure when this project was made, but when I saw it, I got immediately struck, and I wanted to find a way to reproduce it. Of course, in Touchdesigner. He probably, when developed this, did not do it in Touchdesigner because it's something that is available online, and so it's an interactive installation. But we are going to just focus on the concept of kind of, what is going on here and how can we make it in Touchdesigner. A little bit of a disclaimer: we are not going to implement fully what he's able to do here, because I can see that he's using 3D shapes other than a rectangle or a circle, and that adds a little bit of complexity, and I haven't quite figured it out, but maybe in the future we'll see. Or if any of you has some idea of how to kind of take this a step further, let me know in the comments, and I would love to learn. So as of now, this sketch run as you can see here. So we're basically constructing an image by basically UV mapping the image on multiple instances. I'm driving those instances with this little small kind of system here. I'm not sure if you're going to implement this. You can see it from other videos that I posted in the past. It's just a position driven by a speed driven by an acceleration, and basically we are providing an initial position for the particles and then an end position, which is the actual the actual first node over here, which determines the position, the final position of the particles, but also the position where we're going to sample the texture, basically. Yes, of course it works with different images. I mean, here I've added some examples, and it's pretty nice. You can change, of course, the light and the shadow that comes with it, basically. Yeah, simple setup. I think the more interesting part is happens inside the geometry comp, where we are basically sampling the texture which we are providing to the material in different location, and basically remapping it so that it's kind of, we're just exposing an area, and everything in the end will kind of overlap and kind of rebuild the image. Very long explanation. Let's just jump straight into it. As I said, we'll not probably implement the entire thing. I might skip this because it's not really necessary, but we'll see. And hopefully I will remember how to do it from scratch, and let's go. So I will just delete everything and start. I will keep these images just because they're useful and I will need them. And here I just have keyboard in, so classic reset in case we need it, and is also counting up. We can rename this seed. So basically it's a counter. It's a count chop counting up, I'm gonna use it to kind of refresh the seed for the noise. And here I also had a seed initially. Actually, let's remove it. So here I'm just keeping track of the resolution. And to be fair, let's just do it from scratch so you can see how I did it, but it's not anything very crazy. So I'm just gonna call this resolution or res. Then what I like to do, because this slider goes just up to 1, I kind of like to have a slider that I can just quickly tweak. So I will, instead of setting a number there, I can just add a math, not that, a math, and on the range I can just set range to 100, whatever, or even lower actually. We will not need a lot of instances, so let's keep it 50. And then I will just add a null and call it variables, just in case if we have anything else to add later on, we will add that. So we can use that basically now. I can use this slider and I can see how many what the number is on this side. I actually want to round this up as well. Not that it's strictly necessary, but I like to keep things a little bit tidy. So I'm gonna add the limit and round the value to the closest integer. And so now basically I can drag this. Is 0 is 0, 1 is 50, and I can just decide what the resolution of my image will be. So let's start with adding noise. Of course, this is going to be our initial position for the particles. I want this to be 32-bit float and nearest pixel, not necessarily strictly, but I kind of like to see the pixels. I will then drag this in here and set the resolution with the variable that we created. And also we can drag the seed into the seed so that every time I generate new positions for my particles. Cool. So I'm gonna add a null here, and here we want to basically split things and determine basically the position and the scale of our particles that we're gonna use in the geometry. Here I'm just gonna create another null and call it position, or actually original position. All right. I'm gonna create another noise from our null. This will be our scale. I'm gonna turn monochrome off. I want to have different scales on X and Y axis. We can turn this to an RG because we just want to scale on the X and Y. Output should be only noise, so we're not gonna add or modify the previous noise. So this is a fresh new noise. We're just importing the resolution. And then just take it out here, null, and this is, we set the scale. To make things a bit easier, I also want to set this noise to random, so I know that the numbers will be within the range we're actually shown here. So offset is 0.5, perfect. What I like to do, because this, what does this mean? What does this mean? It means that the values will be generated from 0.5 plus minus 0.5 from there, right? So we're gonna have something in the range 0 to 1. But I don't want my scale to be too low. Okay, so I'm gonna copy this parameter, paste it here, paste reference. And then in here, I can just multiply this by 0.8. Again, I don't really care to be too precise, but basically what this means is that if I go, if I move this slider, this one will always be not as big as this. So if in this case, we are just gonna go down to what's that, 0.6 or something like that. We never reach 0 basically, and it's a little bit basically proportional to this slider over here. We will see it better later, but in my opinion, this is like an easy way to keep things a bit more under control. Okay, enough of that. Let's create the rotation. And here I just gonna copy this one. In this case, I want to turn this to RGBA. We want to rotate on every axis, so we need 3 channels. Yeah, so rotation. We're gonna call this rotation. And again, because the rotation in geometry comp is not in radians, but is in degrees, we need to then multiply that, or to have basically bigger numbers than what this, again, I'm really lazy. I don't like to, actually, we can reset this. Sorry about that. So we can reset this. We can also reset this to Simplex 3D. That should be fine. I want to bring this to 0, and now this amplitude is what drives my rotation basically, and we will keep it pretty low, but we will see later. But this value goes again, as we talked earlier, it would go from 0 plus minus this value up here, plus some extra because noise acts a bit weird, but we don't talk about that. So I'm gonna add a math and just multiply this value by 90 or something like that. So, and then basically whatever this spits out, we are amplifying it, and then this will be our rotation. Again, the value should stay roughly pretty low, but anyways, let's do it like that. Okay, so now we set up the particles. I'm gonna start with the rectangle in this case. I'm gonna, I don't think we are gonna need the transform. Let's leave it out for now, and then a null, and then we're just, again, super traditional instancing here. So turn instancing on, and then we're gonna drag this one here, this one here, and this one here. Plug everything in, R, G, and B. And for the position, the rotation same, R, G, and B. And the scale, we're just gonna use R and G. Okay, let's render this out so we can actually start to see something. I'm gonna add, of course, the camera and the light. For the camera, I'm gonna position, because we're gonna work in the space 0 to 1. I don't wanna, just to make things easy, I'm just gonna move the camera basically to 0.5. So in this case, you can see, let me just add an out here. We want to change, so because this is the project that was already open, you can see here there is some distortion happening. This is because I'm rendering, now the render by default is 1280 by 720, but I like to set it up vertically to 1080 by 1920. Here we go, now we are good. But if you will not see this, you will most likely have this very squished, is because you can go into the project here and parameters, right click on project. I hope you can see it. Yes, right click on project here, and basically in the layout you can add these values for width and height, and that means that you're gonna then match basically whatever we are rendering out. Okay, so now we have something, we're starting to have something. I'm gonna also at this point just activate some shadows. I like to multiply this by 3, so we have a high resolution map and soft shadows, and that's pretty much it for now. Can't really see much, but yeah, you can see they're there. Okay, so let's scale this down. Here we go. Also the camera, we can set it to, no, this is not the camera, sorry. View, orthographic, and kind of we can zoom in a little bit. All right. I think we are having enough particles, or actually too many particles. Let's just reduce that number a bit. And also the rotation seems to be a little bit too much. So now you can see what is happening, right? So this slider now is controlling how much we are rotating each particle. Of course, you can change the other parameters of that noise, but for now we just want that slide rotation, right? Again, if we look at the reference, you have this kind of soft, very subtle rotation of all the particles, and that is gonna help us give this kind of collage effect. Good. One thing I did not make yet. So as we can see, if you look here, right? I'm gonna activate this. So with the orthographic projection is not really a big problem, but I would like to keep them a little bit closer together. Now they're very separated. So to do that, I can just go in here and add a math. Right, and then I can go into range and take my blue channel, which is used for the z-axis, and just set it to 0.2 or something. Also because we might want to get some intersection between the planes and stuff like that to get that extra weird effect. I'm just gonna set everything. Not really necessary, but as I said, I just like it to nearest pixel. And basically, so this is the initial setup. Now we have our particles. These particles are sort of positioned within the space 0 to 1. And if that's not the case, we will fix that later. But now we need basically to add a material to our shapes, basically. I'm gonna use a fog material and apply it to the geometry. And now here, this setup is just, I have like 3 images. Could be one image, could be a noise, whatever, not any texture. I have a switch so that I can switch between them, right? And then this effect works best with squared images. So since I don't know if I always have square images, I'm gonna use a fit. Just set to fit outside, right? And that's gonna basically take whatever image you have and make it so that it fills the square with no issues, basically. You can set the resolution of the fit to whatever you want. I left it by default to 1000 by 1000. That should not be a big problem. But you know, if you want a better look, you can increase that resolution. And in the end, I have just my null. I'm gonna use that as the color map. Now here in the material, we can open this little menu here and set the extend to 0. So basically, this means that whenever we are sampling outside the image, the return value basically is 0, or yeah, transparency basically. Okay, it's me from the future. The next part of the video was going to be too chaotic, so I decided not to put it into the final cut. I'm gonna now go through this next part again in such a way that it's gonna be hopefully easier for you to understand. I'm gonna go a bit more into the details of this next part of remapping basically the texture from the way it is right now, basically where all the particles are texture in the same, basically showing the entire image for each of the particle. We want to instead go and sample a particular part of the image relative basically to the position of the particle. I have set up a sketch here to kind of represent a little bit what we are going to do. We can start by talking about the image itself. So this is our texture, right? And now we have that texture on each of our particles. And this is the representation of our particle. This is the position of the particle. And this is the actual object with its size. The texture, or in general, textures are kind of represented through their UV map. So if you are going to sample a texture, you will use the UV coordinates of that image in order to pick colors or or portions of that image. As you might know, the UV coordinate is basically just another representation of the 2D space between 0 and 1, where U is the x-axis and V is the y-axis. And the bottom left corner is the coordinate as 0, 0, and the top top right is 1, 1. Now, you can imagine our particles as being displaced or placed within this space, right? So we have an X and Y position. We also have a Z position, but that's not really important in this case. And what we want to do is then tell Touchdesigner, okay, go to that position and sample this area around it and use that basically as texture for this instance. Now the problem is that naturally we do have that information, right? We have the position, we have the size, so we could in theory pass that here. So first of all, very important that you change texture mode to from replace to transform, and then here we will pass an operator with the information that I'm talking about, position and scale. And then we do have that, so we could potentially pass this X and Y here, or like the R and G channel of the position here, and then the R and G channel of the scale down here. But there is a problem. The way Touchdesigner does this process is basically interpreting the position we are passing as being the 0, 0, or like the bottom corner of this, the sampling area basically. So you can think about it in this way. So if we are looking at this as being the sample area, so if we are passing the position, it's gonna return us this area. So the position being the 0, 0, the sampling area, and then the sampling area size being the scale or the size of our instance. So one simple thing we need to do is to then subtract basically half the size of our instance from the position. In that way, if we are, for example, again subtracting this, let's look at this as being half of the size. If you're subtracting that and you're subtracting also this other size, half of the size, then we would end up down here, right? So this is the would be the point that we are passing to Touchdesigner. The scale would remain the same, but in that way we are then kind of working around this issue and making sure that Touchdesigner would sample the correct area and return that as the texture for that instance. And that's pretty much it. Just remember to change texture mode here from replace to transform, and now old me will take over and take you through the rest of the video. Thank you, and sorry for the inconvenience. As I said, we need to then take the scale and divide it by 2. So I'm gonna take our scale from before here, or actually I can do it from here, I'm assuming. Taking out the math and basically dividing these values by 2 by just multiplying by 0.5. Now I have my position, and let's start from here. Because we want to sample the image actually. So let's think a little bit ahead. Now this position is not really changing, right? We're not doing any animation or anything, but if in the future we want to animate these particles so that they can move around like it happens in these videos, you can see how the circles are moving and they're bringing the texture with them. So we are basically not resampling the image every time the circle or the particles move around. We want to sample it once, or basically based on their original position, and So instead of taking the position from here, I'm gonna take the initial position, right? So we should actually call this, just let's call this position. All right. And then this is the original position. All right. We're getting there. I'm gonna subtract this by basically taking the we could do that actually, but I prefer to just have a composite, drag this in, and then set this to subtract. Now we might have some conflict here, because I guess this is now this is not RG and this is, but it doesn't matter, because in the end we just need, in fact, RG texture. So this is gonna be our position, and then we want the scale of our actually sampling area, which is exactly what we're using to scale our particles. Okay, now we have an issue, or it's not really an issue, because we just need 4 channels. We need the U and V, and then the scale X, U and V as well. So we need in total 4 channels, and RGBA image is 4 channels. So we could, there are 2 ways to do these things, which is, one, we can use a reorder and basically bring this in and set this to RGBA, and then basically saying the red and green channel are taken from the first input. The second input instead it drives the scale and and I also want to take the red and green basically, so that basically the green channel of the scale is actually set in the alpha for this, and the red channel of the scale is set in the blue channel. This works. One other thing though that I prefer to do in this case, also because we don't have a lot of instances, is to use the chop, which makes a little bit like things a little bit cleaner. So I'm gonna just remove this reorder for now, and sorry if you were following me. And I'm gonna take this one as well. So what are we trying to do here? We want to basically take the channels and rename them. So I'm gonna use U and V. Basically, I'm taking the red channel and renaming it U, and the green channel renaming it V. Then we want to output as a single channel, and then in the crop here, full image. So now we're taking our image and basically flattening it out and make a unique channel for all the red channels, for all the red values of each pixel, and the same for the green. And we're going to do exactly the same for this. Remove the blue and alpha, and call these US and VS for V scale. Okay, and do also output a single channel set and set to full image. Now you can merge this. So add a chop, merge chop, and perfect. I'm gonna take a null and call it just sampling data. Again, this is pretty much the same as doing the reorder as I did before, but I feel like in this way it's a bit easier and cleaner as a setup. So again, finally we can drag it down here, and now we are all our data. In this example, for example, like if for some reason you wanted to add the rotation information, you couldn't do that with the reorder because you only have 4 channels available. But in this case, you could do basically the same exact thing and then merge that into one chop, which then you can use in here. And that is why I also prefer this, because should be the case in the future I want to do that, I am already ready to go. So going back to the geo, select it, and then in the instance 2 section, select then U and V, and then the scale, and let's see if it works. Vertical scale, and it seems to be working. So basically now we can scale this up, right? We can scale, you can see how the image is scale, the particles are scaling, and they're scaling relative to their center, and we are also sampling below and above that center. So we have shifted basically the way we are sampling the image by doing this subtraction. And basically we are pretty much done. If you want to add a different image, or sorry, a different geometry, you can add a circle to kind of make it even closer to what the example I showed you from Hübner was. And the important thing here is to set this circle to have the radius 0.5 to 0.5, and that is just to avoid the weirdness in how we are remapping things. So here now, if I switch this, we can see basically the effect stays intact. What I was saying earlier regarding being able to animate the particles is that you don't want to basically move the sampling position with your particles. Otherwise, it looks like basically the texture is sliding over. Let's do a simple example here. So if I add a noise here, and I turn this on and bring it off, and bring the these two values to 0. So now we are not doing anything basically. The output is always by default set to plus. So we are adding this noise to whatever position we have. So you can see that if I'm moving this, I'm adding some information, some value to the position, and that basically the different elements are bringing the texture with them. And if this doesn't break, you could see how if I instead would use the end position, so the one that has mutated basically compared to the initial, if I change this value, you can see how the texture kind of stays in place, and so we are moving the sampling position. And that's not what we want, at least not in this case. But just so you know, if you want to do that, you need to do it in this way. Otherwise, we need to use the initial position. Where did we decide to scatter our particles? And yeah, I think, if I'm not mistaken, that's pretty much it. We can animate this a little bit. Yeah, and so now we have this the ability to just basically take our images and map them onto instances in such a way that we create this kind of collage effect. I think it's super cool, and again, go check out his website, because there is so much good inspiration, especially both case studies and the exploration. There is plenty of cool stuff and to get inspired with, and yeah. So I hope you enjoyed this tutorial. Let's just see how it looks with other images. Yeah, and again, so we can change the scale here, as we already tried to do, right? We can change the position of so let's say I want to have the sampling a little bit concentrated in the middle, which is actually what happens in this example. You can just decide that basically with this range. So as you can see here, we are all the pixels are 0.5 now, but then if we increase the amplitude, we are sampling outside and outwards to plus minus 0.17 relative to 0.5, and that you can see how we are basically now sampling around that center. We can change the scale and the rotation. So again, and the texture you can see comes with it. So we'll rotate together with it. And you can imagine how you can sort of animate and then have these kind of come into place like this, and so on. So it's super flexible system. I really like it. And then you can just go, you know, closer with this and change the shadows with the lights, and yeah, do all sorts of things. So again, I hope you liked it. Like and subscribe to the channel. That would definitely help. I will leave this file into, or I will make it available for whoever supports me on Buy Me a Coffee. So just if you want to get access to it, go check it out. And yeah, if you have any question, please ask. If you have any other things that you would like me to explore, or kind of figure out how to make cool effects or whatever you find online, let me know. And thank you for watching, and I'll see you next time. Peace.